Good morning everyone. I suppose all are good in health by the grace of God. Praise God. We shall start with the third chapter. What is the third chapter? It is force and pressure. We already learned what is force. Force is required to move a stationary object. Also, if an object is moving, I have to apply force to stop the moving object, right? Now, suppose I have a table over here and I want to push, this is a table and I want to move the table. So I am pushing the table. So if I stand like this and do, will the table move? No, I have to touch the table to push it. What type of force am I applying over here? I am using my muscles. So it is a muscular force, okay? Now when I am pushing, I am already touching the table to push it, isn't it? So my hand is in contact with the object. Such kind of forces are known as contact forces. Muscular force is an example of contact force where the object is in touch. When the force is applied, the object is in touch. Forces are known as contact force. Now, what will be the opposite of it? Non-contact force. Are there any forces which are non-contact? Can you think of? Without touching, force is applied. Without touching. Is there any force such? Of course. All of you must have used magnets. If any object which is iron, particle or anything, I bring the magnet. Do I have to touch the object? No. Before touching it only you can feel that objects are moving because of the magnetic force. Okay. You also have done some activities like ruler rubbing on your hair and picking up the paper bits. Are you touching the paper when you bring it to the paper? You can see the attraction over there when you rub the ruler to your hair and bring to the paper bits. What type of force is that? Electrostatic force. So there is no contact, but you can see the effect over there. Okay. Similarly, suppose one fruit is ripe, mango is ripe on the tree and the fruit falls. It comes down. All of us know why it is coming down, because of the gravitational force. Now, is the earth coming up and touching the fruit? No. But when the fruit is ready, it is falling. The force is acting over. We cannot see. The force is not touching. It is not in contact. Such type of forces are known as non-contact force. Okay, so there are two types of forces on this. Whether the object is in touch, that is contact force, or non-contact force. Similarly, there are other two types like balanced force and unbalanced force. Now imagine I have a table over here. Okay, I have a table. I am pushing the table from this side. A person like me stand on the other side and push the table this side. Both of us are applying equal amount of force. How much I am pushing? That much only she also is pushing. Will the table move? The table will not move. Why? Because both of us are applying equal amount of force in opposite direction. If I am applying force like this and the person is along with me here, both of us are pushing, table will move because both of us are pushing in that direction. But here what happens, she is applying from there, I am applying over here. Okay, so the table will not move and both of us are applying on the same table, same object. Such type of forces are known as balanced force. In balanced force, both the forces are applied on the same object in opposite direction and their magnitude is equal. If another person is standing over there, okay, the person is maybe one first standard child standing over there. She is trying to push the table and I am pushing. Which side the table will move? Table will go to that child's place because she cannot apply that much as force I am applying, isn't it? So it is not a balanced force because the table is moving in that. Though it is in opposite direction, the magnitude is different over here. I am applying more and she is applying less. Therefore, you can see the table moving. Such type of forces are known as unbalanced force. Remember that balanced force and unbalanced force both act on the same object. Okay. Now, we come to the next part, that is force. When you learned about force have direction as well as magnitude. So what type of quantity it is, when it has a magnitude as well as direction, such quantities are known as vector quantity. Vector quantities have direction as well as magnitude. You also know that force is required to move a stationary object or to stop a moving object, to change the direction. For all this, force is required. Okay. You have also learned something about inertia. Do you remember? Inertia. What is inertia? Imagine you are sitting and watching TV. Nice entertainment program which you like the most. Okay. Your mummy is calling from behind. Come here, come here. Will you get up? No. Why? It is my natural tendency that I want to watch that program. I don't want to get up from here. So that natural tendency which do not want to change, that is known as inertia. So the natural tendency of an object or a body to continue in its state of action. If it is at rest, it wants to continue in its state of rest. If it is in motion, it just wants to continue its state of motion. So the natural tendency of an object to resist a change in its state of rest or of motion is known as inertia. Imagine you are sleeping. You like to continue to sleep. That is the natural tendency. Any change brought to that, your body doesn't want to accept. So that natural tendency to resist the change, that is known as inertia. Now, there are three types of inertia. Inertia of rest, inertia of motion, and inertia of direction. Inertia of rest, that means the object is at rest. Object is at rest, doesn't want to change that resting position. Just want to continue to be resting. That is known as inertia of rest. For example, suppose you are sitting in a bus which is halted. Bus is just standing, not yet running, just standing over there. You are sitting in a bus, okay? Suddenly the bus starts. What happened to you? You will get a backward jerk. Why do you get a backward jerk? Because you were at rest and your body want to continue to be in rest. So the body is resisting to the change brought to it. That is why it goes backward, because it was in that position. Okay, that is inertia of rest. You have inertia of motion. Inertia of motion means the object is in motion. When the object is in motion, it wants to continue to be in motion. Doesn't want to stop, doesn't want to change to that position. Okay, just want to continue. So any obstacle brought to that, the body will react. That is known as inertia of rest. For example, suppose you are in a moving bus. Bus is moving. You are also along with the bus. In the bus, moving. Suddenly, if the driver applies force, brake. Suddenly, if the driver applies brake, what happened to you? You are in moving. Okay. Suddenly, the driver is applying force. You are standing. Imagine. Then what happened to you? You will still go forward. Why do you go forward? Because your body was in motion. Now, body doesn't want to bring any change to that. It will resist to any change brought to that. So, body still want to continue. So, you will get a forward jerk. Okay. That is inertia. Similarly, you have the example of fan. You switch off the fan. Fan is in moving. Fan is moving. If you switch it off, will the fan stop at once? No. Fan still goes slowly to stop because it doesn't want any change brought to that motion. Okay, that is inertia of motion. Inertia of direction. Inertia of direction means doesn't want any change brought to the direction. Suppose an object is moving in straight line. It wants to continue to be in straight line. Doesn't want to take any twist or turn. Okay, that is known as inertia of direction. Imagine you are moving in a car or vehicle or anywhere in a straight line. You are just going straight. If the vehicle take a turn, you will also get a jerk. Why? Because you are also going in a straight line. You don't want any change. So the resistance causes you to get a turn. Okay. That is inertia of direction. What is inertia? Inertia is the natural tendency of a body to resist any change brought to its state of rest or of motion. Just want to continue to be, if it is resting, want to continue to be in rest. If it is moving, just want to continue to be in motion. Okay, any change brought to it, the body tries to resist it. That resisting part, the natural tendency is known as inertia. Three types of inertia: inertia of rest, inertia of motion, inertia of direction. We have that activities also respect to that in your book. Please learn about it. Okay. The next topic is all about pressure. What is pressure? We hear lot of pressure. So much of pressure. What is this pressure? Pressure is the effect of force. When I am applying force, you can see the effect of it. That effect is known as pressure. Okay. Suppose I have a nail. I want to put it on the wall. Imagine this is my wall. One side is sharp and the other side is round, flattened. Okay. Now, when I want to put the nail on the wall, which side will I put towards the wall? Sharp edge. Why? Is there any relation between the sharp edge and the force and the pressure? Suppose I want to put the nail on the wall, I have to apply some force, isn't it? When I apply force, I am banging, that is applying force, and I am hammering it. Okay, if it is a sharp edge, it will go inside. So when it is going inside, you can see it. That is the effect of the force that I am applying. Suppose I am putting that round or the flattened head part of it, how much ever force I try to apply, will the nail go inside? Nail will not go inside. You will be only going on applying force on it. Can you see the effect of it? No. So what is pressure? Pressure is the force applied on unit area. What is force? What is pressure? Pressure is the force applied on unit area. Now, what is the unit of pressure? How do we get the unit of pressure? What is the unit of force? The unit of force is Newton. Unit of area is meter square. So what is the unit of pressure? Unit of pressure is Newton per meter square. Newton per meter square is also known as Pascal. It's also known as Pascal. Now, when we calculate the atmospheric pressure, it is a high quantity, then we will be using the term bar. Okay, we will be using the term bar. 1 bar is equal to 10 raised to 5 Pascal. 1 bar is equal to 10 raised to 5 Pascal. We are talking about pressure. What is pressure? Pressure is the effect of force. The definition. What is the definition of it? Is the force applied on unit area. Okay, force applied on unit area. But the unit of it, Newton per meter square, which is also known as Pascal. Now, if you look at it, okay, as I said, suppose this is the nail. Okay, the nail have a sharp edge and a head part of it. Okay, the sharp and the edge part of it, what do you call this top part of it? This is known as the surface, and this is known as the surface area. So if you look at the pointed edge and the head part, where is the surface area more? Surface area more is at the head side of it. Okay, now pressure is equal to force upon area. Area is in the denominator. More the area. When you look at the nail, where was the area more? More was at the head part of it. More the area, will you see the pressure of it? Pressure is the effect of force. More the area means you are keeping the head part of the nail and banging, applying force. Will you see the effect of it? Will you see the pressure of it? No. The nail will not go inside. So smaller the area, smaller was the area at the sharp edge. So smaller was the area, pressure you could see it went inside. Okay, you can see they are inversely proportional. Inverse. It is in the denominator. More the area, pressure will be less. less the area, pressure will be more. That is why it is easier to cut with a sharp knife than a blunt knife. If you look at a blunt knife, you can see the surface of it. It is little broader than a sharp knife. You are applying equal amount of force. Okay, you are using, suppose you have both the knife, one is sharp and one is blunt. You are applying equal amount of force. Which one will be easier to cut? With the sharp. Why? Because the area of it is less. If the area is less, which area we are talking about? Surface area. If the surface area is less, then the pressure will be more. You can see the effect of it. Okay? Okay. Now the pressure on solid, liquid and gas. How the pressure effects, okay, on solid. As I said, if the area, surface area is less, more pressure will be seen. Suppose you are in the railway platform and all, you have seen these coolies, they put some round thing on their head before they put their luggage on top. Why? Because when you put that round, you can see the top of a head is a little pointed. So something is kept over here. Entire force will be on that particular. So it will be more painful. Suppose it is flat over here, so that the surface area increases over here. If the surface area is increasing, the force effect of it, effect is the pain, the way that we feel, okay, that effect will be less. That is why they put that round thing around it. Similarly, if you look at the bag, straps of the bag, they are very broad, okay. If they are fine and if you have lot of things in it, you can feel the pain on your shoulders. So why they should be broad? If they are broad means their surface area is more. Surface area is more, the force, what is the force? Means the weight that is pulling it down, okay. So effect is that pain that you feel. So if the surface area is more, then the pressure will be less. That is why the strap should be broader, okay. You can also see one diagram given to you in your textbook, okay. You have it in your textbook. You can see over here, the books are kept, okay, books are kept together. You can see the plank coming down because the area is less over here. Since the area is less, you can see the effect of force, that pressure. Look here in this diagram, they are spread. When they are spread, you can see that the area is more. So the area is this much over here, where the area is this much over here. So you can you see that plank is straight over here, it is not coming down. But here you can see that is the pressure seen over there, okay. Now when you look at it, liquids can be all that is flowing, they are known as fluids, okay. All that flow is known as fluids. Liquids as well as gas comes under fluids because they flow, okay. In liquid, how is the pressure seen? You take a balloon, you put it under the, before Holi and all, when you play you do it, no? You take water in it, when you fill water in it, you can see that entire balloon comes up. So that pressure is exerted equally in all sides. In liquids and in gases, the pressure is exerted equally in all sides. Similarly, when you blow a balloon, you can see that it get inflated on all the sides, not only one side, okay. And it put pressure on the walls of that balloon, on that container where the liquid is taken also, okay. Now, as the depth increases, the pressure also increases. Suppose you have a plastic bottle, you have a bottle filled with water, okay, and you make holes on that. You have a bottle, okay, you have a bottle, you make holes, one hole is on top, one is over here and one is over here, and you fill water in it, you fill water. If you open the cork of it, you will see that this will be falling like this further, this will be still, this will be falling closer, okay. This is going still more further when it falls out. Why? Because as the depth increases, the pressure is more. As the depth increases, the pressure is more. That is why the dams the walls of the dams towards the bottom, they have to be very, very strong, because the water content, as the depth increases in the dam, towards the bottom, the pressure will be too much. Otherwise, the wall can break. That is why the dam's walls towards the bottom, it has to be very, very strong. As the depth increases, pressure also increases. If you look at the gas pressure in the atmosphere, we know that we are surrounded by a lot of pressure, atmospheric pressure. As you go higher and higher, okay, as you go higher and higher, the atmospheric pressure decreases. Now, we are standing over here. We know that pressure is too much. There is full of atmosphere surrounding us. Why are we not crushed? It is like you are keeping maybe 100 kgs of apple over here, 100 kgs of apple, and a truck is coming and falling over it. Okay, truck falling. What will be the condition of the apple after the truck falls on it? It will become smashed, fully smashed. That much like is the pressure that is falling on our head, on us. Then why are we not crushed? Why are we not smashed? It's all because in our body there are fluid, there is pressure. A lot of fluid, blood is there, water is there, enzymes are there. Also there is a lot of cavity in the bones and other parts. Okay, so that cavity and that fluid, they equal to the pressure outside. When the pressure is equal, they are balanced, so we don't feel it. We are not crushed. Otherwise, so much of pressure is there on us, we can be crushed. Why we are not getting crushed? Because there is a lot of fluid. What fluids are there? Water is there, enzymes are there, blood. So that pressure equal to the pressure outside. Sometimes they say those who are climbing the mountains, as you go higher and higher, they feel breathless. Why do they feel breathless? Because as they go higher, the atmospheric pressure decreases and your body got a lot of pressure. That pressure is more than the outside pressure. So the pressure tries to go out of your body than coming in us. Okay, so there is imbalance. That is why you feel that. Also feel that air is popping out when you climb. Why? As you climb, inside pressure is more, outside pressure is less, and pressure always flow from high level to a lower level. Only they also say they don't advise to take fountain pens in the plane. Why? Because fountain pens are filled with ink. As you go in the flight, as you go higher, what happens? The pressure decreases, and we fill ink in the fountain pen when we are on the earth, on the surface. Okay, so that pressure is more than the pressure above. So when the pressure imbalance, pressure always flow from high to lower. So fountain pen, since the pressure is more, it tries to flow out, that is spill out, the ink spill out. Therefore they advise not to take the fountain pen ink pens on the plane. Okay, so we have seen what is contact force, non-contact force, examples of it, balanced, unbalanced, inertia, types of inertia. So seen pressure, what is pressure, unit of pressure, pressure on solids, liquids and gases. Okay, there are two subtopics more over here. One is Archimedes principle, and then we also have buoyant force. Very simple topics, we'll cover it out. What is buoyant force? You take a tub of water, or when before going for bath, you fill the bucket. You take an empty plastic bottle with a cork. Try to push it inside. When you are trying to push it inside, what happened to it? You can feel that pushing it up. It's very difficult for you to push it down. What is forcing that bottle to come up again and again? That force, that perpendicular force exerted by the liquid is known as buoyant force. Okay, so when you are putting an object, the so the perpendicular force applied by the liquid is known as buoyant force.
Buoyant force. What is buoyant force? Let us understand the meaning of the term buoyant force by performing simple experiments. Push a cork down into water taken in a trough. What do you observe? The cork rises up and comes up to the surface as soon as we release it. Now to keep it beneath the surface of water, we have to exert a downward force. This means that the cork is experiencing an upward force. The upward force is due to the force exerted by the water. The downward force which we exert counters the upward force. This shows that when a body is partly or wholly immersed in a fluid, the fluid exerts an upward force on the body. The upward force experienced by a body when partially or wholly immersed in a fluid is called upthrust or buoyant force.
Because if I leave this ball, you can see it bobs up. Why? Because water is pushing it with an upward force. And this upward force is also known as upthrust or buoyant force.
Buoyant force depends, how much buoyant force applied depends upon density of the liquid and also the volume of the object. If you go to the seashore, just take a nail, put it in the water, sea water. What happened to the nail? It goes inside, isn't it? But you see the mighty ship floating. Why? What is the difference? The volume of the object. The volume of the nail is very small. So less the volume, buoyant force is less. It goes down. But the volume is more, buoyant force also is more. So it will be pushing it. What is buoyant force? The perpendicular force applied by the liquid. Okay. The volume is more, force also is more. So the ship can float. Okay. Also depends upon the density of the liquid. It is easier to swim in sea water than in fresh water. That is, if you are a swimmer, you can experience it. Okay. We also have an example. Okay. I have taken lime. Okay. It may not be so visible to you, but if you look at it, you can see that in this lime is higher than in this. Okay. The difference in these two is I have put some salt in this liquid. When the salt is there, density is more. And when density is more, buoyant force also is more. So you can see the buoyant force, that is the force applied by the liquid towards the lime, is more. That is why lime is floating. Okay. Now, when we speak about buoyant force, okay, we said that depends upon the volume of the object and also density of the liquid. When do we say that the object floats in water or the object will sink in water? If the buoyant force is more than the weight of the object, buoyant force is more than the weight of the object will be floating. If buoyant force is less than the weight of the object, then it will be sinking. Okay. If both are equal, then you can see it floating in between. Fine.
For this experiment, I've taken this hollow ball and I've filled it with coins here to make it heavy. Let's measure the weight of this ball, which is filled with coins, with the help of this spring balance. So let's see what is the weight here. So as you can see here, the weight is 500 grams. Or to be more precise in physics, the weight is 500 gram force. But for this video, we'll just keep things simple and use gram as the unit of weight. And this weight is known as the real weight of the ball because it is the weight in air. Now I'm going to immerse this ball into this beaker of water and you carefully observe what is the reading of the spring balance. So I'm going to lower the ball here. So what did you observe? As you can see, the spring balance shows that the weight of the ball when it's immersed in water is now 300 grams. So there is a loss in weight when the ball is held in water. So why is that? It's because of the upward force of the water. And the weight in water is called as the apparent weight because the ball seems to lose weight. And how much is this apparent loss in weight? it's the real weight minus the apparent weight. So it's going to be 500 grams minus 300 grams, that's 200 grams. So the loss in weight is 200 grams. And we know that the upward force is contributing to this loss in weight. So the upward force is actually the loss in weight, which is 200 grams. Or to be more precise, 200 gram force. Now let's take a look at the second part, that the upward force is equal to the weight of the water displaced by it. So I'm going to go ahead and tilt this larger beaker so that the displaced water goes into the smaller beaker. So let's try it one more time.